Hey everyone! In this video, I'm going to do a demo of signing certificates with OpenSSL. I might be joined by my cat. He's around my chair here, so if you hear meowing in the background, that's what that is. He just wants to help out, and he wants to learn OpenSSL too. So, certificates. Why might you use them? Certificates are part of a subfield of cryptography called asymmetric key cryptography. And the basic idea is that you have a public key and a private key. The public key is what is exposed to the world and is used by other people, entities, computers to communicate with you. And the private key is what you have to either verify what they've sent you or encrypt things that you're sending to them. So basically, without going too much into the gory details, there's a big equation, and basically by performing some operation with the private key on some piece of data, then sending it across the wire, and then performing the same operation using the public key, you get the original piece of data back. And the same works conversely as well. Encrypting something with the public key, sending it across the wire, and then decrypting it with the private key also does the same thing. And there are, there's a right way to do it and a wrong way to do it, and depending on what you're doing, for instance, if you're doing SSL encryption, that's one thing. If you're doing server and client certificates, that's another thing. So one of the common misconceptions is that HTTPS, right, what we commonly are referring to when we say SSL, is just encryption. That's not entirely true. It's both encryption, because the data itself is encrypted, but it's also verification. So the server has a certificate that the client can validate. Another aspect of SSL is that it's all based on trust. And this is where the concept of signing comes into play. So in order to do the cryptography piece, all you need is the public and private key. But in order to do the validation and have that multiple degrees of trust, you need a signing piece. So the public key is also usually referred to as a certificate in this case when it's signed in this way. So the public key has been signed by someone else's private key, and that means that that signature can be validated based on the publicly available cert. This chain of trust has to start somewhere, and that's where we have something called root certs. These are certificates that we trust implicitly, and there are only a few of them out there. You can certainly install your own root certificate. In some cases, this is called certificate authority. You can install your own on your own machines that you manage, and that might be the case if you have a closed network. So let's say a corporate network, you might have your own certificate authority and corresponding certificates that go along with that, so that you can sign as many certificates as you want within your organization. Those certificates are trusted because they have the chain of trust installed on all the machines. Everything's good. Of course, when you go out to the internet, you do need to have your certificates signed by a root certificate authority or something called an intermediate certificate authority, which is basically a certificate authority whose certificates have been signed by usually a root certificate authority, though you could have multiple chains. You could have a root and then an intermediate that then signs all your certificates. But the important part is you need that chain of trust. You need that series of signatures. So I think that's enough for the explanation piece. So let's switch over to a demo, actually, and let me pull up my cheat sheet here, because I am not going to remember these commands. So here I have, this is Windows Subsystem for Linux in the Windows terminal, or the Microsoft terminal, Windows terminal, I think is what it's called. You can download the Windows terminal from the store. Go ahead and check out Scott Hanselman's channel for all the customization of the Windows terminal that you could possibly need to know about. That's why my terminal looks, halfway decent. It looks basically like a Linux machine, but it's not. It's running on my Windows machine. So let's start out very simply. Let's do a self-signed certificate. And there are actually two ways to do this. So the first way, I'm going to do the kind of the long way, and then the second way, I'll do it all in a single command. So this all starts with the OpenSSL command, the OpenSSL binary. OpenSSL is technically a reference implementation for libopenssl, the OpenSSL library. But it also has a ton, I can type a ton of useful things, and it's kind of the de facto way to build certificates, at least on the Linux side of the house. There are some commands on Windows, but I think OpenSSL is kind of the de facto standard, so that's why I'm using OpenSSL. So these are all the commands that you can have with OpenSSL, and we'll actually get into this specific one, and you can get help for that as well. So you can get some information on that. Let me clear my terminal, and to start out with, we're going to create a private key. Again, if I can type OpenSSL genrsa to say we want to create an RSA key, and we'll specify an output file, and it's going to be, let's just pretend we're creating a ca key. Actually, let's before I do that, let me go into a directory just so that I don't have certificates lying all over my system. Okay, so OpenSSL genrsa -out. We'll call this ca.key. These will be in PEM format, PEM, but there are some typical extensions that are used just to indicate what's a public key, what's a private key, what's a certificate signing request, and you'll see some of them. Mainly because OpenSSL doesn't care about the extension, it just cares about the contents of the file. And by looking in the file, it can see that it's in PEM format. So, ca.key, and then 4096. This indicates how many bits are in the key, because we're talking about math here. Cryptography is just really big numbers. So 4096. And it'll go ahead and create a key. If I ls, you can see ca.key. If I open that up, you see there's a private key. This is base 64 encoded, but it's a really big number. Okay, so let's do the next step, which is to sign the key using itself. And this creates a certificate. So OpenSSL rec, because we're in effect creating a certificate signing request and immediately signing it. So rec is the command, -x509 is the format that we're going to use. This is what's used for certificates. This is the certificate format. The key that we're using is ca.key. And then we'll dump it out into a file called ca.cert. Again, we're creating a certificate signing request, but we're also signing it. So we're going straight to the certificate stage without stopping at the CSR stage. So to do that is to specify a length of time that we're signing for. So let's say just a year. We'll say days 365. And it'll ask for some information. This is the information that would show up if you pulled up the certificate details in a web browser, or if you went to import it, especially on Windows, you'd get a little preview of kind of the information on the certificate. And these are the questions, these are the answers that it would show there. So country, we'll say US, state, Colorado, I'm going to leave city blank. Organization name, we'll just say Brian Parks. Organizational unit we'll leave blank. Common name, this is our CA cert, so we'll say Brian Parks CA, or root CA. Email address, I'll put my email address. And it's done. So if we ls, we see we have a new cert. And if we open that up, we'll see begin certificate, again, some base64 encoded data, and end certificate. Now, we can actually use OpenSSL to kind of show us what's in there. So for this, we'll use the x509 command, again, because we're dealing with something that's in x509 format. And noout, because we're not writing any files out. Dash text indicates that we want to print some information to the screen. And the input file is ca.crt. And we get a bunch of information. And you can see here's the answer to all of those questions that I answered. Brian Parks root CA, Parks Brian Parks.me, US, Colorado, right? Validity dates. Today is October 7th, and it's valid for the next 365 days. So cool. Now remember I mentioned that you could do this all in one command. So let's do that. So OpenSSL rec -x509. Now so far it looks the same as when we signed the key using itself. But in this case, we're going to tell OpenSSL to create a new key by providing the -newkey option. And give it some information, say RSA is 4096 bits. Give it a place to put the key, so we'll just say not ca.key. The output file, not ca.crt. Days will be 365. And no DES just indicates that I don't want to save the private key with a passphrase. So you can see it did the first step of creating a private key, and now it's asking me the same questions for the certificate. So I'll give the same answers. US, Colorado, okay, there we go, all done. If we ls, you can see we've got ca.cert, ca.key, the ones we created in the first set of commands, and then not ca.cert and not ca.key. So now, that's if you're doing a self-signed certificate. And that's helpful if you just want to get a certificate up, running, quick and dirty, nothing fancy. But what if you want to use a certificate to sign another certificate? So in this example, I'm going to assume that you have a CA certificate. You have a certificate that is designed for use as a certificate authority. In this case, I'm going to use the CA cert that I just created. Obviously, in order to use that anywhere and have it be trusted, I need to install the CA cert in the list of trusted certs on whatever system I'm using. But let's say that you actually have a valid CA cert. This is how you would do it. So first of all, you do need to create a new private key. So we already know how to do that. OpenSSL genrsa -out. I'm going to call this securable.key and 4096. Okay, boom. We have our key, our private key. Now, with this private key, we create a certificate signing request. And in this case, we're not going to sign it using the same key, so we have to do this in multiple steps. So OpenSSL rec-new, provide the key, which is securable.key, and provide the output file, so securable.csr. Let me verify with my notes that I have everything I need, and there we go. And of course, it does ask you for all this same information, because this is the information that will eventually be in the certificate. So US, Colorado, Ryan Parks. Let's say Ryan Parks.me. Let's say I'm using it for SSL, maybe. And then my email address. You can optionally provide a password. This is just an additional layer of security. You do need to tell whoever's going to use this certificate signing request what that password is. So let's just say password, optional company name, we'll say Brian Parks. Okay, all done. Now we have securable.csr. Let's see what's inside of it. So certificate request, also in PEM format, bunch of base64 encoded data, and let's go ahead and sign that. So we can take the CSR and sign the certificate that's encapsulated inside of it. So let's see, find it in my notes. Here we go. OpenSSL X509. Again, that's our target format. Dash rec means we're coming from a certificate signing request. The in is securable.csr. We need to provide a certificate authority. That would be ca.crt. We also need to provide the key. So that would be ca.key. Ca create serial. This is necessary because, well, basically OpenSSL will die if you don't provide this. And obviously we're going to create a certificate, securable.crt, and how long we want it to be valid for. So we'll do 365. Boom. And now we have securable.crt, securable.crt. There we go, we have a certificate. And we can use OpenSSL to inspect it as well. OpenSSL X509, noout, text, in is securable.crt. And here's all the information from the certificate. Awesome. And now, the one last thing that I want to add in this video is, what if you're on Windows, like I am, and need to import something into the trusted key store, or the trusted certificate source. Windows doesn't necessarily use PEM, without doing some conversions. Windows likes a format called PFX, or more accurately, PKCS12. OpenSSL has support for that, so if I go OpenSSL help, there is a command somewhere in here, PKCS12. So let's do that. OpenSSL PKCS12, and we'll use the export option, and the input is the securable.cert, and it does need the key. So inkey is securable.key, and the out will be securable.pfx. You can provide an export password. I just used password, super secure. And that's basically it. Now, we can see what that looks like over here. So certificate files are recognized by Windows, but PFX are probably the best thing for you. And you can actually import them. You got some information, and here's where you would specify the password, and right, you could import that. Now, if you wanted to look at the certificate, you could open that up, and you can see, obviously here, certification path. There's you might not be able to see that. Let's see if I can zoom in. Yeah, so right here, you've got an exclamation mark because the root CA is not installed on this machine. So in order to do that, I would actually convert the CA to PFX format, import that, and then the trust chain would exist on this machine. So with that, that's pretty much everything that you might want to know about using OpenSSL to create and sign certificates. Now, if you found this video interesting, go ahead and like it, share it as well, subscribe to the channel. If you have questions about OpenSSL and how to use certificates, go ahead and leave those down below as well. I've got lots of videos on this channel, both technical and non-technical, so be sure to check those out. Subscribe, hit that notification bell to be notified when I post a new video. Thanks for watching, and have a great day.